Chapter 3, Decisions, Part 7. It's common to try to combine relational operators just by chaining them together the way you would in math class, as in 0 less than or equal to temp less than or equal to 100. We've been doing that since first grade when thinking of a number line and putting things together. And while it works in math, it does not work in Java. We would have to break that in. It doesn't work in Java because the relational operators are binary, and so they need a valid expression for each operand. So 0 less than or equal to temp, that's going to be true or false, right? So that would result in a true or false. So we'd be comparing a Boolean less than or equal to 100, which is an integer. So we can't have that mixed type, Boolean and integer, as operands. They all have to be numeric. So instead, we would have to say 0 less than or equal to temp and temp less than or equal to 100. Also not allowed in Java is saying something like if input equals 1 or 2. While we might say that in our speaking, what we really mean is if input equals 1 or input equals 2. We have to have that complete Boolean expression, that complete true or false on either side of the relational operator. It's also common to confuse the and the or conditions. Typically that happens because our English doesn't line up with our logic. If a value lies between 0 and 100, if it's at least 0 and at most 100, we say if a value is greater than 0 or less than 100, that or is not what we mean. We mean and. And if it lies outside a range, we say if it's less than 0 or greater than 100. But sometimes in speaking we might use and instead. But there is no golden rule. You just have to think carefully. And or are also short circuit evaluation operators. So what that means is, let's look at the short circuit evaluation for the and operator. If temp is less than or equal to 0, that means that that first expression, temp greater than 0, that would be false. So do we even need to go take a look at temp less than 100? We don't, because it doesn't matter. And requires both Boolean expressions to be true for the entire expression to be true. So if we know that the leftmost one is false, that condition can never be true, and so it stops evaluating and just continues on with the expression. We can use this short circuit evaluation to our advantage when we say something like if quantity greater than 0 and price divided by quantity is less than 10. The advantage here is if quantity is not greater than 0, we might encounter a divide by 0 error when we say price divided by quantity. However, as long as we're relying on short circuit evaluation with the and operator, we won't run into that problem. So if quantity is equal to 0, that first expression would be false, and it will skip the if statement entirely, causing us to not have a divide by 0 error, which is a runtime error. Our program will crash if we have that. If we reverse the order and had price divided by quantity less than 10 and quantity greater than 0, our short circuit evaluation would no longer work in our favor. We could still encounter that runtime error. So be careful about the order in which you put these Boolean expressions when you're forming compound expressions. The short circuit evaluation with the OR operator works just the same way, except that because OR says that either expression must be true, with short circuit evaluation and the OR operator, if temp less than or equal to 0 is true, then it stops evaluating. It doesn't go test if it's greater than or equal to 100 because it knows that it's going to be a true expression. So it goes and prints not liquid. De Morgan's law is a law that tells you how to negate and or conditions. So if we had not parenthesis A and B close parenthesis, it's the exact same as if we said not A or not B. So notice, just like the distributive property that you used when you were in elementary school, we can distribute that not, but we have to flip the logic operator to the other one. So not parenthesis A and B close parenthesis is the same as not A or not B. So not parenthesis A or B, close parenthesis, is the same as not A and not B. And we can use that in our favor when we are evaluating shipping charges, as you've seen before. I think that the expression if not country dot equals USA and not state equals AK and not state equals Hawaii is a little bit more difficult for the human mind to follow. We would benefit from saying, oh, we're missing a set of parentheses. We would benefit from saying if not country dot equals USA or state dot equals Alaska or state dot equals Hawaii, shipping charge equals 20. It's a little bit more clear. The problem with the expression on the right-hand side and that gray box on the right-hand side is the entire Boolean expression needs to be in a set of parentheses like it is on the left, and it's not. That's a typo. To simplify the conditions with negations of and or expressions, it is usually a good idea to apply De Morgan's law to move the negations to the innermost level. Input validation. We want to make sure that our user is entering valid input, because if not, we're going to have to behave differently, and frequently our user can enter stuff we don't expect. So in the scanner class, there is a method called hasNextInt. So if the user has typed an integer, we can use hasNextInt, and if that's true, then we're going to get that integer. If that's false, we want to display a message to the user, that's not an integer. And that will help us validate the input and make sure that that our program doesn't crash. Here's an example of the elevator simulation again, but in this case at line 13, we've used that if not in dot has next int. So what we're doing there is we're saying if that expression is false, we know the user entered an integer. That's not true. It should not have the not sign there. I'll have to validate with your textbook to make sure that that is the way it appears in the textbook, but that not at line 13 should not be there. We want it to be in dot has next int, because if there is an integer, then we want to get that integer at line 17 and then evaluate it as follows.